Hi, Assalamualaikum. I am Muhammad Khalizuddin bin Abdul Qasim with method number DE190132. So today I will present our group, which is group 5 for Engineering Mathematics 4 group assignment. Our problem is the temperature versus draft problem. The method that we use is from chapter 4, which is interpolations. First of all, I would like to thank our lecturers, which is TS Dr. Muhammad Afi bin Ayub and Dr. Haida bin Dimad Akil for guiding us throughout this project. So this is our group members, starting from Muhammad Hanif bin Nasbullah with method number DE190157, Rais Haikal bin Rasul Hamidi with method number DE190151, and me myself, Muhammad Khalizuddin bin Abdul Qasim with method number DE190132. So the next part is table of contents. Firstly, the introduction of one authentic engineering problem. Secondly, it's about methods. We choose two different numerical methods to solve the problem. The third one is result and discussion. This part is about the simulation in Microsoft Excel and manual calculation. And the last part is conclusion, including the individual reflection and contribution in the group. So the first part is about the introduction. The purpose of this project is to increase the number of best scored in a leg. It is recommended that the line be drawn to the depth of the benchmark line. The characteristic feature of the area is the sudden temperature change. The data collected with a specific range of pair values, including such temperature and depth, and we need to estimate the appropriate temperature value when the depth value is negative 7.5. To accomplish this project, we use the interpolation methods, which is to approximate the value of function. To accomplish so, we use interpolation methods. To accomplish so, we use the interpolation methods, which is to approximate the function fx at the intermediate depth point within a discrete dataset range. Interpolation should be done by using two methods, which is Lagrange interpolation and Newton's divided difference method.
Hi, Assalamualaikum. My name is Raif and I will explain to you about the methods. There are two methods that my group is using to solve the problem, which is the first one is the Lagrange interpolation method, and the second one is Newton divided difference method. Now here you can see the formula of Lagrange and Newton divided difference method. To find the Pn equal to F0x and Fx0 and so on, where Lix is equal to that equation. For the Newton divided difference method, you can see the following formula. Okay, step 1 for Lagrange interpolation method, we construct the data in tabular form. I towards 10, we use 10 data, and then Z in meter, starting from negative 10 meter, and then minus 1 and 0, 0, and then the temperature. Okay, step 2, we need to find the L0 and F0 using the formula that is given above. And then we substitute the value in the above equation, and then we get the P of 10, which is negative 7.5 equal to 15.3913. Okay, for Newton divided difference method, step 1 is constructing Newton's divided difference for temperature and depth for a lake. Okay. Step 2, the first Newton divided difference is calculated as below. That is the formula. Then we just plug in the value of each interval. the next step is to put the value as well using the formula. And then the third step is to put the folder. Well, we essentially uh, fulfill we fill in the table in the step 1 and then follow the formula accordingly until we fill up the table, which is in step 12. In step 13, we need to summarize, we need to sum all of the calculated value that we did before. And then we can get the B and the F of negative 7.5, which is the same one as the Lagrange method. Well, close is 15.3375. That is all from methods.
Hi, my name is Muhammad Hanif bin Hasbullah. I will continue part of presentation in result and discussion. Our group project, we are using the Microsoft Excel for our simulation. So we go to the Microsoft Excel first. Okay, this is for the method one that we use, the Lagrange interpolation. So we in Microsoft Excel we need insert the all formula that we discussed into the chapter 2. So we just insert the formula not F not until L10 F10. So we can get the answer automatically and we get the value same with the manual calculation. For P10 negative 7.5, we get the 15.3930. So this is for the method 1 Lagrange interpolation. So for the method 2, so this is for Newton divided different method. Still same, we just insert the all formula here and we can get the result will appear automatically. So we get for on approximation negative 7.5, 15.3379. I can conclude this project. This project must determine the value of temperature when the depth of lake is negative 7.5 meter in this outer engineering problem. Also need to figure out what the relationship between lake temperature and depth. Therefore, to know the temperature at depth for a lake with a depth of negative 7.5, because the temperature between negative 8 and negative 7 is not reliable or not significant. As a result, the equation that depict the correlation between the depth and the temperature has been simplified into the equation. So we get the approximate negative 7.5 is 15.3930.
The next part is conclusion. In conclusion, the outcome was achieved successfully as both manual calculation is the same result as those achieved in Microsoft Excel. Both with Lagrange interpolation and Newton divided difference may be the best option, but depends on few factors, particularly when dealing a real-world or true engineering challenge. In this project, we were able to improve our communication skill towards each other and complete the manual calculation before executing it in Microsoft Excel by having a group discussion. We organized a few online sessions to avoid any unintended errors and discuss any difficulties to complete this project.
Okay, my reflection and contribution to the team is upon completing this group project, I was able to learn more about interpolation and Newton's divided difference method and Lagrange method. After having a group discussion, I also learned to calculate using this method and apply it to our group engineering problems. This project teaches me to give good teamwork to all my group members at school. Cooperation and group work helps to solve the engineering problem in the group project. As my contribution to this project, I did the manual calculation for Lagrange method and discuss it with each other how to obtain the results of the method to apply it in Microsoft Excel. Teamwork is a good opportunity for the team to exchange ideas and come up with creative ways of doing things. Lastly, the most important part is I have gained so much knowledge upon completing this project with my team members. Thank you.
Next is about the reflection and contribution to the group. After completing the group project, I understand the Lagrange interpolation method and Newton's divided difference method and how to apply them to a real-life engineering problem. By having a group discussion, I believe that good teamwork among every member is very helpful to solve the problem regarding the assignment, as everyone gives full cooperation. For my contribution to this project, I have my members to do the report and manual calculation of this group project. Our group have a discussion together on problems and questions on this project and how to use Microsoft Excel to compare with the result from manual calculation. Apart from that, the task was distributed well to all members, which helped us to complete the assignment with good teamwork. All progress was done by the discussion in WhatsApp group and meeting through the Google Meet platform.
Okay, for our reflection and contribution to the group. First, I learned how to apply the formula in Microsoft Excel and how to insert the formula inside each column through this group project. For my contribution to this group project is to perform the manual calculation and simulation in Microsoft Excel, and as well as to comment report. Besides that, I discussed how to solve the problem with my group member using the method that we approved, and also we can do this group project on time and finish. In addition, I have learned that excellent cooperation requires communication between team members, so group project can be easily developed and complete.